Okay, this video is all about quadratic word problems in factored form. Our model problem here, a rocket is launched from its platform. Its height in meters, x seconds after the launch is modeled by h of x equals -4 times x plus 2 times x minus 18. Now, it's always beneficial and very much suggested to draw a visual of what our parabola looks like in real time with what our model problem is talking about. Because this is all about real life situations, our graph that we need is really only the first quadrant portion because it's the positive values. So a rocket is launched from a platform. We think of a platform up here on your y-axis. And this is your x-axis. So a rocket is launched, it launches, it reaches its maximum point, and then it goes down and hits the ground. So that launching point right here would be known as your beginning, your y-intercept. And remember, at your y-intercept, we know the value of y, but we do not know we know the value of x is 0. But we need to find the value of y. So x is 0 at the y-intercept. Then it reaches its maximum point here. So the max, remember we're talking about, or the question is asking for the maximum value. We know we're dealing with the turning point. So whether we're dealing with the x value or the y value of our turning point, that would be determined in our problem. So if it's the x value, we're looking for the time period, because normally we're talking about time for our x-axis, and then usually the height or distance for our y-axis. So if it's looking for the maximum height, we would be looking for our y value. How long it took to reach that maximum height would be your x value. And then the last point to consider is when the rocket hits the ground, how long it took you. So this would be your x-intercept, which is also known to us as our root. And you would look for the positive value of your roots, not the negative value, because in this case, in the first quadrant, x is positive on the right-hand side. All right, so once you have a good visual of your topic that we're talking about here, then you can go ahead and answer the questions and use that visual to help you figure out what you're actually solving. So what is the height of the rocket at the time of the launch? So the time of the launch is right here. It's our starting point. And our time at that point is 0. So x equals 0 at the time of the launch. So we want to know what that height is. So we're looking for our y value of our x, of our y-intercept. So that means wherever we see an x in our function, we are going to place in 0. So we have -4 times 0 plus 2 times 0 minus 18, and we get -4 times 2 times -18. -4 times 2 is -8 times -18 gives us 144, and since we're looking for our height is in meters, so 144 meters. Okay. So we are looking here for our y-intercept. For letter B, how many seconds after the launch will the rocket hit the ground? So again, we're looking for seconds, so we're looking for that x value, right? We're looking for our x value after it was launched. So when it hit the ground here, this is where it hit the ground. So we're looking for our root. So we're looking for our roots here. And we want to remember that we are looking for a positive value of a root. In order to find our roots, we need to take each one of our factors and set them equal to 0. So -4 equals 0, x plus 2 equals 0, and x minus 18 equals 0. In this case here, we know that -4 does not equal 0, so we're going to ignore that one. And we want the positive value. X plus 2 equals 0. We subtract 2 on both sides. We get x is equal to -2. And we have x minus 18 equals 0. Add 18 to both sides, and we get x equals positive 18. Okay, so now we need the positive value because we can't be -2 seconds after it was launched. So we are going to disregard that one. So we're going to have the rocket will hit the ground after 18 seconds.